theta is equal to minus 45 degrees. Okay, right? Because it's going anti-clockwise, and theta relative to the z-axis, right? Anti-clockwise is going to be negative. Okay, so from here we know that tangent pi is equal to iz prime. So iz prime is 21.4 divided by 6.74, and this will be multiplied by tangent minus 45. Okay, so pi will be equal to tangent minus 45 times by 21.4 divided by 6.74, and then inverse tangent is equal to minus 72.518 or 0.5. Okay, degrees just one decimal point. So what does this mean, right? So now I'm going to take my protractor. Now this is from z-axis and going what? Counter clockwise. Okay. So now this will be equal to minus, I'm going to draw in green. Okay. I'm going to sketch this in green. So this will be equal to 71.5. Okay. And this is the position of your neutral axis. So this is your neutral. No more centroid here. It's your neutral axis. So this angle over here, right? This angle over here is equal to 72.5 minus 72.5 degrees. Okay, I'll write properly. So from here, so the question asks relative to the horizontal line. Okay, so the angle, right? This is the angle we're going to find, and this angle we call it our what's another, our alpha angle. Okay, so we know that alpha angle is equal to 72.5 or minus 72.5 plus by what? 45. So it's equal to minus 72.5 plus by 45 is minus 27.5 degrees. And you just need to put in that this is going in a anti-clockwise direction. Okay. So to quickly capture what we've learned, okay, always the transformation, right? You rotate your transformation, right? This over here relative to the diagram. So it's much easier to analyze. And always remember the moment vector starts from the center and point where? Point outwards, right? Point outwards. Okay. Right. So this a lot of times students get a bit confused regarding this this problem. So the next thing that we want to find, because point C is the position of the neutral of the not neutral of the centroid. Okay, so point C is the position of centroid. So the next thing that we want to do is we want to find the stresses at point A, B, and D. Okay, we want to find the stresses point A, B, and D. So let me get it sorted out, right? So again, next we want to determine the stresses at point A, point B, and we want to find at point D. Okay, so we know we use our again our moment vector. So we know that this is our moment, this orientation over here. This is our moment in our Y, right? This looks weird. Oh, I think I know why it looks weird. My bad. So this is moment about Y. And if you use right hand rule, right, you're going to grab. So this is under compression. And this is under tensile. Then if we look at moment about Z, I'm going to do orange in color. This is our moment. Again, right hand rule, you grab about Z. So we are now going to calculate our moment about Z. Okay, so we know that it's 45 degrees. So my is also equal to mz, right? Because it's 45 degrees. So this is equal to sine 45, then multiply by 15 times 10 to the power 3. Okay. So sine 45 times by 15 power 3 is equal to 10.606 or 607 times 10 to the power 3 pound inch. Okay. Okay. So from here, we want to find stress X at point A, right? So if again, you have to get all this clear. What is your Y direction? What is your Z direction? So at point A, Y of point A is equal to what? Y. So you look at, so this is the Y orientation. This is the Z orientation. So Y itself is 4 inches, right? And then Z at point A, right? So Z at point A, right? So the Z direction is 0.859 inches, okay? Then all we need to do now is apply the formula. So you just put my over Iyy multiplied by Z, mz over Izz multiplied by Y, right? So at point A, moment about Y at point A will give you compression, right? So negative. And then moment about Z. So if we look at the moment about Z based on the moment vector, this is compression. Over here is tensile. So from here, you realize that moment about Z for point A is going to be positive. Okay. So next we just put in the numbers. The numbers are the easy part, is the analysis. Okay. So minus 10.607 times 10 to the power 3 divided by Iyy. So Yy is equal to 6.74 multiplied by our Z distance, which is 0.859. Then plus again, 10.607 times 10 to the power 3 multiplied by y distance, which is 4, and then the whole thing divided by IZZ. So IZZ is given to us 21.4. So when we calculate this, 10.607 power 3 times by 0.859 divided by 6.74 is equal to minus 1.352 times 10 to the power 3. Let me try it again. 10.7 power 3 times 0.859 divided by 6.74, 1.352, and plus 10.607 power 3 times 4 divided by 21.4, 1.983. So this will be equal to minus 1.352 plus 1.983, 0.631 times 10 to the power 3 psi. Okay, so minus 1.352. Yep. So that's A. And then for B, right? So Y for point B, right? So the Y distance of point B relative to the Z-axis is 4 inches. And Z distance of point B relative to the Y-axis, right, is equal to 0.859. So you realize that the Y and Z is different, but what is different is this, okay? So stress X at point B. So this is equal to my over Iyy multiplied by Z, and you have mz over Izz multiplied by Y. So the difference is this. So if you look at moment about Y, okay, it's also going to at point B now. Okay, at point B, the moment about Y is going to generate compression, and mz is also going to generate compression. Okay? So no doubt the magnitude of the Y and Z coordinates are the same, but what stress are they going through? Both of them are going through compression. Okay, and then all I need to do is I just need to copy and paste this because the numbers are all the same. Right, the numbers are all the same, except for, so this is also minus. So the value over here is 1.352, and then I need to minus again. Is equal to minus 3.335 times 10 to the power 3 psi. Okay, right. Let's take a 5 minutes break, and we come back again. Okay.